the velocity of sound is greatest is air, water, steel, aluminium, kerosene. We know that velocity of sound is increasing with density of medium. In increasing density of medium, velocity of sound increases. Therefore, we have to compare density and we have to get the medium with highest density. When considering air, water, kerosene, air medium has a small velocity of sound. Water and kerosene are liquids. Therefore, velocity of sound should be greater than air medium for water and kerosene. Steel and aluminium are solid medium. Therefore, there is a maximum velocity for steel and aluminium. We have to compare density of steel and aluminium. We know that density of aluminium is less than density of steel. Therefore, we can observe maximum density for steel. Then we can observe highest velocity of light, velocity of sound for the steel medium. Answer should be 3. If the velocity of sound in air at 0 degrees is V0, temperature at which the velocity becomes 2V0 is. There are two relationships for velocity of sound, gamma P over rho root or gamma R T over M root. We can consider velocity of sound is directly proportional to square root of Kelvin temperature. We have to consider absolute temperature, not Celsius temperature. Then we can get V directly proportional to square root of Kelvin temperature. For the first situation, velocity is V0, temperature is 0 degrees Celsius. We have to convert it to Kelvin, 273 Kelvin. And we have to find the temperature when velocity of wave is 2V0. I will consider that temperature as T. Then we can divide these two equations. We can cancel out V0 and V0. We can get the square. 1 squared 1, 2 squared 4 should be equal to square root of 273 squared, 273 divided by T. Now we can subject T value 4 times 273, 4 into 3, 12, 1 remaining, 4 into 7, 28 plus 1, 29, 2 remaining, 4 into 2, 8 plus 2, 10. It is in Kelvin. We have to find the Celsius temperature. Then we can subtract 273 from this value. Then we can get 819 degrees Celsius. Then answer should be 4. The quality of sound depends on its frequency, amplitude, wavelength, loudness, presence of overtones. We know that pitch of the sound wave is depending on frequency. Loudness is depending on amplitude of the wave because of loudness is depending on the energy of wave. Energy of a mechanical wave is depending on amplitude. And quality of sound is depending presence of overtones. Then answer is 5. Pitch is depending on frequency. Loudness is depending on amplitude. quality of sound is depending on number of overtones, and we can consider shape of wave. Velocity of sound in a gas is at 27 degrees is V. The temperature at which the velocity of sound in gas becomes 2V. Same thing like this question. Then we can get velocity of sound directly proportional to square root of Kelvin temperature. Velocity of sound directly proportional to, they have given initial temperature as 27 degrees. It is 300 Kelvin. We have to add 273 to convert Celsius to Kelvin. Then we have to find the temperature for this velocity, 2V velocity. We can divide both the equations. Then I will get the square. 1 over 4 equals 300 over T. Then temperature, absolute temperature 4 times 300, 1200 Kelvin. We have to subtract 273 to obtain Celsius temperature. Then it is 927 degrees Celsius. Answer is 4. Which of the following could influence the speed of sound in air? A. Frequency of sound wave. No. We know that frequency of a wave is depending only on source. It is not depending on passing medium, or it is not influence for velocity. Then A is incorrect. B. Temperature of air. We know that when increasing temperature, we can observe high velocity of air, therefore it is correct. Humidity of air. Yes, we know that when increasing humidity, we can observe high velocity. In increasing humidity, there is a high velocity of sound. Then B and C are correct. Answer is 4. Consider the following statements made regarding the speed of sound in air. A. Speed increases with the increase of pressure when the temperature kept constant. According to P equals 1 over 3 rho C square bar. When increasing pressure, density also increases with same ratio. Therefore, we know that velocity of sound is gamma P over rho. When increasing pressure, there is a same increasement of density. If we are double the pressure, density also 2 times of initial value. Therefore, velocity is not changing. We have to remember that velocity of sound is not depending on pressure. Velocity of sound is not depending on pressure. Then A is incorrect. Statement A is incorrect. Then statement B, speed increase with the increase of temperature and humidity. Yes, it is correct. We have obtained it in previous question. Statement A, speed increases with increase of pressure when temperature kept constant. It is false. B, speed increases with increase of temperature and humidity. Yes, it is correct. See, speed decreases with the increase of density when the temperature kept constant. No, when increasing density, pressure is increasing with same ratio, then C is incorrect. When increasing density, pressure also increasing with same ratio. Therefore, velocity is not depending on density. Then answer is B. Only B is correct. It means answer is 2. But we have to remember there is a problem related to this question. We can increase density by using another gas. It means if we are mixing a high density gas for the given gas, pressure will not change because of pressure is depending on number of moles according to PV equals nRT. Therefore, statement C also correct, but they have not given the answer that B and C correct. They have given only B is true. The gas is confined to a closed container. Consider the following statements made regarding the speed of sound in the gas. Statement A, the speed of sound does not change when the volume of container is changed at constant temperature. Yes, we know that when decreasing volume, pressure is increasing. But according to T equals 1/3 rho C square bar relationship, when increasing pressure, density also increasing with same ratio. Therefore, we can get statement A is correct. Velocity of sound is not changing with volume. Part B, the speed of sound changes with temperature. It is correct. C, the speed of sound changes when more gas is added to the container at a constant temperature. Yes, it's also correct. All A, B, C are true. Then answer is 5. A source of sound is located at a point O above the Earth's surface. In the daytime, the air temperature decreases gradually. When moving upward from Earth's surface, which of the following figure best represents the way in which wave fronts of the sound emitted from the source are propagated? When moving upward from Earth's surface, they have given temperature is decreasing. We know that when temperature is decreasing, velocity of sound also decreases. And according to V equals F lambda, F is constant, it is depending only on source. We are not changing source. When velocity decreases, lambda wavelength decreases. Wavelength, we can represent wavelength as the gap between two wave fronts. Then gap between two wave fronts should be decreased with height. Then answer should be C. Consider the following statements made regarding speed of the sound. A, speed of sound in air increases with the increase of temperature of air. Yes, it is correct. B, at a given temperature, the speed of sound in a metal is higher than air. Yes, we know that when the medium density increases, velocity of sound also increases. Then part C, the speed of sound depends on the frequency of sound wave. No, it is incorrect. Speed is depending on medium, not corresponding wave, corresponding frequency of the wave. Then A and B are true. Answer is C. Two ideal diatomic gases A and B of volume VA and VB respectively with different densities at the same temperature and pressure are mixed together. The mixture is maintained at the above temperature and it can consider as an ideal diatomic gas. If UA and UB are speeds of sound in gas A and gas B respectively at the above temperature and pressure, then the speed of sound in mixture will be given by velocity of sound wave is not depending on pressure. Therefore, we have to get a relationship for density. I will consider velocity of sound gamma p over rho root. Then we can get for the gas sample A, velocity of sound is given as UA, gamma p over rho A root. I will subject rho A from this equation. Then we can get rho A equals gamma p over UA squared. By using same method, we can write density of sample B, gamma p over UB squared. There is the same pressure. Therefore, P is constant. Gamma is depending number of atoms in a gas. So in a gas molecule, they have given both gases are diatomic. Then I will consider the mixture. When mixing gases A and B, we can get density equals mass divided by volume, then mass equals density into volume. Therefore, for the mixture, we can get density equals mass over volume. Mass is density into volume of gas A. We know that density of gas A, gamma p over UA squared into volume VA plus density of gas B, gamma p over UB squared into volume VA divided by VA plus VB. It is the density of gas mixture. Then we can use this equation, velocity equation for gas mixture. Velocity of sound equals to gamma, pressure constant P over. We can substitute density as this one. Gamma P VA divided by UA squared plus gamma P VA divided by UB squared. We can bring this VA plus VB to the numerator. VA plus VB, and we have to put square root. Then we can cancel out gamma P for all terms. Then we can get V equals VA plus VB divided by LCM of denominators VA squared UA squared UB squared. The numerator should be UB into VA plus UB into VB root. Then we can simplify it. We can get this term to the numerator and it is a perfect square. then we can get square root of it, UA, UB. Square root of VA plus VB divided by this one should be UB squared VA plus UA squared VB. Then UB squared VA plus UA squared VB. V means volume. Then answer should be 2.